Before we get started, I have a quick favor. I've been self-funding the Finding Genius podcast for 5 years now. I've done over 3,000 episodes. And as you can see on YouTube, we're up over 1 million views on the channel, which is fantastic. The next thing I really want to push on is to get up to 10,000 subscribers. Because once we do, we'll be able to put a donate button and we'll be able to solicit donations to help keep the podcast running and to also get the Finding Genius Foundation moving along. We have a big project studying anxiety, depression, and PTSD and working on a product to help people overcome these problems because I've seen them explode recently after the last 2 years of the whole virus situation. So if you would, please subscribe to the podcast. That would help us tremendously. Give us a thumbs up and check in the description for Buy Me a Coffee. It's about $5. If you could buy me a coffee, I'd really appreciate it. It would help keep the channel going, and I love coffee. Thank you. Most people have heard of phytoestrogens, but did you know there are beneficial phytoandrogens that mimic and support testosterone and more? The top source of these is pine pollen. If you're looking for 100% natural hormonal support for men and women, you've got to try this. Right now, Lost Empire Herbs' best-selling pine pollen is available for 1 penny plus shipping and handling. Go to geniuspollen.com to find out more and grab yourself a bag today. No hidden charges, no trial offer, no shenanigans. Just a low-cost way to try Lost Empire Herbs' top product for next to nothing.
Forget frequently asked questions.
Common sense, common knowledge, or Google.
How about advice from a real genius? 95% of people in any profession are good enough to be qualified and licensed. 5%
go above and beyond.
They become very good at what they do, but only
0.1%
are real geniuses. Richard Jacobs has made it his life's mission to find them for you. He hunts down and interviews geniuses in every field: sleep science, cancer, stem cells, ketogenic diets, and more. Here come the geniuses. This is the Finding Genius Podcast
with Richard Jacobs.
Hello, this is Richard Jacobs with the Finding Genius Podcast, now part of the Finding Genius Foundation. I have Thomas Stanton. He's an AXA Research Fund Fellow at Loughborough University. We're going to talk about plastics and microplastics and anthropogenic materials. So that's what we're going to work on. Thomas, thanks for coming.
Thanks for having me.
If you would, tell me a bit about your background, how you got into microplastics and the research areas you're in.
Yeah, so I think like most people, my interest in microplastics and plastic pollution sort of stemmed from reading the news and seeing news articles and TV coverage of the problem of plastic pollution. I was lucky enough to be at a very supportive university as an undergrad student reading about this stuff, and they kind of let me loose with a couple of projects that the start of my research journey, I suppose, and then that ultimately led on to a master's degree and a PhD, and ultimately what I do now as a researcher in the field of plastic pollution and anthropogenic materials and more broadly, water quality.
So what are you researching now? What questions are you trying to answer?
So my work at the moment is primarily focused on textile fiber pollution. So the pollution that comes from our clothing when we wash it or when we wear it in our day-to-day lives includes these tiny fibers, microfibers. So they're frequently grouped with microplastics, but they're not all plastic. So cotton fibers, wool fibers, and they still shed from our clothing as we use and wash them. And what my work at the moment is doing is looking at how these fibers are lost from garments, how they move through particularly river systems, and then how they interact with chemicals in the environment. So how they potentially pose a chemical risk as well as a physical risk. So the physical risk of these particles, just like all microplastics, is that they can entangle and block the guts of particularly small organisms that ingest them, and then they can accumulate up the food chain as well to higher trophic orders.
So where do garments tend to lose their fibers? Do they just lose them all day long? Is it primarily in the wash?
It's primarily in the wash. The laundering of clothing and drying of clothing, particularly if using tumble dryers, for example, is a major source of these textile fibers, but they do come off as we wear them. I always tell people to put a glass surface down when they're folding their clothes, their dry clothes, and you'll see all the fibers deposit on something like your phone screen. So they do come off just through normal, as we're putting them on, as we're taking them off, as we're walking down the street as well, but a lot less.
As a shirt or pants or whatever it may be gets washed, does it release more fibers over time or less? Or there are certain points where the structure of a garment starts to break down in one spot and a hole forms, and then maybe preferentially lots of fibers come out near that hole or that tear?
It's exactly that. So we find that the majority of loss sort of happens in the early washes of a garment. So a lot of garments that come to us from the shops or from online retailers have actually been pre-washed, so they may have had a lot of fibers shed from them already. You may then get a sort of more stable period of more consistent shedding, and then, as you say, once the garment starts to break down and degrade and it gets holes in it, there's essentially a greater area from which fibers can be lost, and the structural integrity of the garment starts to decrease.
So when someone has like a favorite old shirt, partner's telling them throw it away, they're saying it for more reasons than one, I guess, reasons they don't even know. Huh?
Well, if it's a good quality shirt, it might not be falling apart. But yeah, if it is just a rag, then yes.
Yeah, no, I'm just teasing. What kind of clothing tends to shed more or cause more problems? There's synthetics, then there's natural clothing like wool, cotton, etc., or somewhat natural. So what kinds of clothing are, how do they shed differently? Rayon, etc.
So the majority of work that's looked at this has focused on plastic clothing, polyesters, our nylons, our acrylics. There's been some work on natural textile fibered garments, so your cottons and your wools and stuff. But to be honest, there isn't enough of an evidence base for me to say either way, whether it's natural or synthetic garments that shed more. Part of what I'm hoping to do, or I will be doing with my current fellowship. But it's so variable, the research that's out there at the moment. We know that a lot is coming off. That's kind of the take-home message, but we've still got a way to go to try and understand how it varies between garment types.
So in the wash, have you looked at cold versus warm wash or hot wash? And, I don't know, in the beginning, is that when a lot of fibers come off and then it slows down throughout a wash? Or is it just, do tons of fibers come off? What happens?
So the majority of work that's looked at this has basically just taken the effluent that comes out of your washing machine, and they've changed the cycles. They've changed whether the application of fabric softener, for example, can influence it, temperature, spin cycle, all those sorts of things. So there's less work looking at which stage of the washing process sheds fibers, and that's something that I'm kind of in the processes of looking at the moment, but I haven't had a chance to crunch the numbers just yet. But it really depends on the washing machine. So not all washers are the same. You can have a 30-degree cotton cycle from Bosch washing machine, and that's not going to be the same as a 30-degree wash cycle from another brand. So it's compounded by the fact that we have such variable washing procedures and washing machine settings, that it just makes it that little bit harder to answer questions like that, unfortunately. But that's the direction that a lot of research is going. So hopefully we will have those answers soon.
Yeah, do you think at some point that an extra filtration step will be required on the outlet of laundry, on washers and dryers to reduce the number of fibers that get into the waste stream of water?
So it already is in some parts of the world. So there's legislation requiring that in France. There are pros and cons of it because those filters then have to be removed. So the user has to know how to responsibly dispose of these filters, clean these filters. We don't want people to then just go and wash the filter down the sink and wash all the fibers straight into the drains that ultimately the washing machines feed into as well. But yeah, it's certainly an option, but it's not the only one.
Okay. What about when clothing goes into the dryer then? Does it make it friable and do a lot more fibers come off? Or is the drying just prepare the clothing for next time? Or does it accentuate the loss of fibers?
Well, I think you only need to look at the link collectors of drying machines to know that they do lead to the loss of a lot of fibers. I haven't in my work been looking at whether or not the drying itself changes the likelihood of fiber shedding subsequently. So I wouldn't be able to comment on that from sort of a scientific angle.
Oh, is there anyone looking at that?
There likely is. I'm not aware of anything. I can send you some links to some papers and have a look if that would be useful, but I'm not aware of anything off the top of my head, no.
Well, I'm just curious. Maybe you're handling the washer part and then some other scientists are handling the dryer part.
Yeah, I mean, a lot of people don't use dryers. A lot of people also don't use washing machines. A lot of people wash directly into lakes and rivers where they don't have the sort of sanitation infrastructure to wash either in home or in sort of community laundrettes. So that's a different angle as well. They're washing directly into these water bodies. There's no interference or no possible interference from filters. And they then have no option to dry their clothes other than to dry their clothes naturally.
Yeah, they'll dry it on like clotheslines outside.
Yeah.
Hang them up.
Yeah, exactly.
I see what you mean. So what, what are the nature of the fibers that come off, do they tend to get tangled in each other and end up in clumps, or do they stay individual and then curl around or cause havoc with biological organisms that meet up with them later on? Like, what happens?
Both of those things can happen. Sometimes the fibers are just free and loose and they can work themselves free. They may well clump. So basically what comes out of a washing machine is a mixture of a lot of individual fibers in suspension and also clumps of fibers.
Okay.
And then these go down our wastewater infrastructure, where we're lucky enough to have it in the parts of the world that do have good sanitation, to wastewater treatment plants, and they'll get mixed up. Some of them will settle out, become part of, sort of the solid part of the treatment process, and others will remain in suspension and flow out through effluent channels. So yeah, we tend to get, well, from the work that I've done, I haven't seen big clumps of fibers coming out of wastewater treatment plants. The fibers that I've seen coming out of wastewater treatment plants and in rivers and in the atmosphere have been individual fibers. But that's not to say that they don't come off in clumps and then get sort of disaggregated into individual fibers on their journey to the environment.
Most supplements are taken on faith and can take weeks or months to have an effect. Even supplements backed by scientific studies may or may not deliver those same benefits to you. But what if you could feel the results of what you took within just a few days? Lost Empire Herbs offers the highest quality, wild-harvested, non-irradiated pine pollen, and that can dramatically impact your hormones fast. Right now, you can grab it for 1 cent plus shipping and handling at geniuspollen.com.
Right, in a wastewater treatment plant, does the flocculation step kind of agglomerate a lot of fibers, or, does this cause problems for wastewater treatment plants if the level is high enough?
So we certainly find that wastewater treatment plants have a very good ability to remove textile fibers from their influent. So the concentrations of fibers flowing into wastewater treatment plants are a lot higher than the concentrations flowing out in the effluent. Frequently we find it's sort of in the order of 95% plus removal. So the processes that incorporate the solid particles, like flocculation, like your more standard settling procedures that incorporate these fibers into the sediments, are very effective. We then have issues where, with what do we do with that solid material? A lot of it is spread onto land, agricultural land, as a fertilizer. So we then introduce these textile fibers along with a lot of other pollutants into the soil environment. And when it rains, of course, they can be washed off into neighboring water bodies, so rivers, lakes, ponds, and ultimately the ocean.
Yeah, that's terrible. Do you know if anyone's modeled to see if biofilms form on the fibers? That they tend to accumulate their own microbiome, you could say?
Yes, we know that biofilms do form on, they form on pretty much any substrate in aquatic environments. So that will include things like plastics and microplastics, including textile fibers, and also natural textile fibers as well. So they do form their own colonies of biofilm. Whether or not they're unique to the fibers, I've not seen. There may be some work out there, but I'm not an ecologist, bacterial ecologist, or algal ecologist. So that sort of thing kind of goes over my head, I'm afraid. But they are colonized by biofilming communities, yes.
And what bodies of water do they tend to accumulate in more than others? Like where's their path typically go? I know it can go anywhere, but what's been observed?
So we know that these particles, these fibers, are in marine environments, including marine sediments. We know that they're in feces of animals that live in the marine environment as well. We know that they're in atmospheric deposition. We know that they're in rivers. They are everywhere. Their ultimate sink, many might say, is the ocean. That's where all of our rivers flow. But along the way, they can get caught up in terrestrial environments, so they can get incorporated into the soil. There's been some work looking at how the activity of invertebrates in the soil can move microplastics into the subsurface, where they are more likely to be retained for longer periods of time. And along the courses of rivers, we have lakes, of course. And at the bottom of lakes are sediments. They're kind of time machines of what's happened upstream of them. They incorporate a lot of natural material, things like pollen and diatoms, but also pollutants. And we know that microplastics and textile fibers have been found in lake sediment records as well. So they're very, very pervasive, and where they tend to concentrate does depend on many factors beyond just the environment themselves. So the social factors, the economic factors of the catchments, the other things that are in the catchment that they might get trapped in. So, for example, if we've got a large dam, it's going to stop a lot of material going down to the ocean. So it's quite a hard question to answer, to be honest, because the environment is so variable. But the take-home message is that they are everywhere.
What about the length or the morphology of fibers? Again, some are alone, some are together in clumps. Have you seen anything that governs the behavior of the shapes they end up forming?
In terms of whether or not they form clumps or stay as individuals, do you mean?
Yeah, I mean, I know that the shapes are probably infinitely varied, but is there a preferential state? So when fibers end up in salt water versus freshwater versus brackish, etc., is their fate any different?
No, I would expect not, but that's more of a question of the physics of the particles, I suppose. I don't know whether or not the density of the water would have an influence on the flocculation of them. Again, that kind of comes down onto the fact that there's an infinite variety of concentrations of fibers in these environments that will also have a play. What you need to answer those questions is some experimental work where you can control for all of this. You can go out into the environment and make observations about the accumulation of fibers in an environment and the length of fibers in an environment. But those environments are so variable that we can't just say that it's typical without sampling a lot more than an individual study is really capable of doing. So there would certainly have to be some laboratory-based work there to look at the actual mechanisms. So that's something that's going to come later on in my fellowship, looking at how these textile fibers of different polymers and different morphologies move through freshwater systems.
Before we get started, I have a quick favor. I've been self-funding the Finding Genius podcast for 5 years now. I've done over 3,000 episodes. And as you can see on YouTube, we're up over 1 million views on the channel, which is fantastic. The next thing I really want to push on is to get up to 10,000 subscribers. Because once we do, we'll be able to put a donate button and we'll be able to solicit donations to help keep the podcast running and to also get the Finding Genius Foundation moving along. We have a big project studying anxiety, depression, and PTSD, and working on a product to help people overcome these problems because I've seen them explode recently after the last 2 years of the whole virus situation. So if you would, please subscribe to the podcast. That would help us tremendously. Give us a thumbs up. And check in the description for Buy Me a Coffee. It's about $5. If you could buy me a coffee, I'd really appreciate it. It would help keep the channel going, and I love coffee. Thank you.
Well, again, what about saltwater systems? Is anyone modeling those in comparison? And is anything noticed different?
Not that I'm aware of using these kind of mesocosm approaches, these kind of lab-based studies. I'm very much a freshwater scientist. I don't have that understanding of how marine systems move and work and change through time to be able to apply that to the work that I'm doing.
Okay. So what are some of the additional questions that you're trying to answer with the upcoming fellowship?
So in addition to looking at the shedding of fibers from different garment structures and different fiber types and looking at how they move through river systems, I'm going to be looking at the chemistry of these fibers. So if we expose these fibers to different types of freshwater system, do they leach chemicals from the sort of fiber manufacturer? So things like the dyes, for example, to different levels. How does that vary between different fiber types? And then also, how do these fibers interact with other chemical pollutants? So we all know that plastic and microplastic pollution is a big problem, but they're only really the tip of the iceberg of the pressures we're putting on the environment, but particularly freshwater systems. So I'm going to be looking at how textile fibers interact with other ubiquitous pollutants, so things like pharmaceuticals and heavy metals and persistent organic pollutants as well. So do they act as sinks for these pollutants? Does one fiber type have a greater affinity for these pollutants than another fiber type? And then ultimately, how long do they stay sorbed? Are they likely to be very long-term sinks, or do they pose the potential to act as a vector for these pollutants to different environments as these fibers travel through a river or maybe the sea as well?
Yeah, I would think just like biofilms form, I would think that the fibers, when they're in any body of water, they would preferentially absorb certain materials. Like you said, they form biofilms in certain cases. I would think, again, certain elements in the water in the water column, or certain organisms would find homes within the fibers or adhere to them, or certain molecules might adhere to them or desorb from them, like you said, at different times. Is there any preferential nature to these fibers where they, they're charged? I don't know, they create a microenvironment again for certain organisms to adhere to them, or certain chemicals. Has that been studied?
Well, that's kind of one of the things that I'm going to be doing with the fellowship. These are generally relatively long chain polymers. They're pretty stable chemically, the plastics, but also cotton. So cellulose, for example, was a very stable polymer. The way that the chemistry works, the mechanisms of the chemistry, you'll have to ask a chemist, I'm afraid. But that is ultimately what I'm trying to find out, not necessarily the mechanisms of the kinetics, but I'm going to be focusing more on the kinetics of the absorption and desorption itself.
I gotcha. Okay. So what do you expect to be able to figure out in the next few years with your fellowship? So you just mentioned this question. What else do you think might come of it?
So the kind of bigger picture here is we know that these natural textile fibers are very common in the environment. So some of my earlier work, some of the work coming from my PhD, found that these natural textile fibers dominated the samples that I was looking at, and that's been repeated subsequently by people all over the world. So we know that these natural textile fibers, the cotton and the wool, particularly the cellulosic fibers, so things like cotton, are very prevalent in the environment, and they outnumber synthetic, our plastic textile fibers in many cases. However, these textile fibers have been marketed, these natural ones have been marketed as green alternatives to plastics. They're saying, if you want to buy clothes, buy natural fibered clothing. We've had people or companies market natural fibered clothing as biodegradable. There's evidence to suggest that this is not the case, particularly in aquatic environments. And so the motivation behind this fellowship is to better understand the relative impacts of natural textile fibers compared to synthetic textile fibers, our plastic textile fibers, so that consumers can make more informed decisions, and also to inform the industry as to the realities of this, because this boils down to greenwashing. We've got these companies stating that natural textile fibers are more environmentally friendly than plastic textile fibers, and the only evidence that they have, or that they're actually really using to support these arguments, is that they're not plastic. They haven't actually looked to see if these natural textile fibers are themselves going to be causing harm in the environment.
I see what you mean. Well, it might be difficult. You would confound it maybe with sheep or other animals from where the fibers came, if they're natural. Cotton, no, obviously, but how much do they shed? I guess that's work for someone else to do.
So yes, I mean the other thing there, and this is particularly why we're looking at the leaching of these fibers, is that yes, wool is a natural material. There will be wool fibers in a field full of sheep, but wool that's been treated by people to possess color and other technical properties is not natural. And how do those modifications that we make as humans to that natural polymer potentially have negative impacts on the environment whilst those fibers are present in rivers, in the soil, in the sea? It's a bit of a clearer message when we talk about cotton. So cotton is a form of cellulose, and when you pick cotton off a plant, it is the sort of common cellulose 1 form of cotton of cellulose. Sorry, so cellulose 1 is a very common cellulose polymer, but when we process it for the garment industry, we actually transform it through a process called mercerization into a different polymer to cellulose 2. And this is a much more thermodynamically stable polymer that's much more resistant to degradation. So yes, if you made a garment out of cotton from a plant, it would be much more likely to biodegrade than a plastic one. We haven't got that same evidence base for the types of cotton that actually come off our clothing, the cellulose 2 form.
Okay. Does anyone, or will you have a setup where you have, let's say, a tank of water that will be sloshing around, and there'll be some fibers in it, and you can model the degradation of the fibers, or again, model what sticks to the fibers? Are you going to be able to set that up, or do you know of anyone in the field that has set up an apparatus like that to observe in a lab environment what happens?
No, I'm not aware of anyone doing that, and I unfortunately don't have the time within my fellowship to explore that myself. It's a really good question. It's a really good idea. It would certainly enhance our understanding, but again, it's compounded by the fact that the environments that we'd be trying to model are just so variable. It would be very hard to do something like that for a river, for example, and make a statement that is representative of rivers. I think there's a big drive to sort of quantify numbers of fibers in the environment or rates of degradation, and they're important questions. But the underlying issue is that we know that these fibers are there, we know that they're very abundant, and we know that they're a problem that we need to do something about. We're always in search of those numbers. Do we distract from the sort of more pressing issue? So as interesting as that is academically, the relevance to the real world scenario of understanding fibers in a river, if we take that example, is, I would argue, quite limited.
Well, it's not going to give you exact answers by any means, but it could give you orders of magnitude, could show effects that, may also show up in the river. It could be, I guess, that if nothing else, a directional guide about where the research may want to go by modeling it like that. Again,
you make a very good point, and I think it could perhaps make reflections on, if you're studying a river of certain characteristics, then you might want to consider X, Y, and Z, certainly. But again, going back to rivers, they are so variable. There would have to be some quite broad categories, I think.
And I guess I would expect these plastic fibers to be hydrophobic, right? I mean,
yes.
Do they develop? Do they integrate into the water at all? Good, yeah.
Sorry,
do they end up attracting any hydrophilic elements where they? I don't know. I don't know what would happen, but I guess they're heavy enough and big enough to fall through you're right. They could fall through the water column. They could be carried along. I mean, anything could happen.
So, I mean, they really could. We know that these fibers are throughout the water column and ultimately can end up in the sediments. And biofilming, as you touched on earlier, is a big contributor and driver to the sinking of these plastics. We know that, yes, they do attract hydrophobic pollutants as well. And of course, biofilms themselves accumulate chemical pollutants within them. So if you have a biofilm on a plastic that then gets ingested by an organism at the bottom of the food chain, we've got, problem on top of problem on top of problem there.
Yeah, no, it makes sense. Well, very good, Thomas. Where can people find out more about your work?
And so I have a profile on the AXA Research Fund webpage and on the Loughborough University website. They can find me on Twitter at Dr. T. Stanton. Yeah, if they want to email me, my email address is on my university profile as well.
Very good. Well, Thomas, thanks so much for coming on the podcast. And I know it's a very new area, but I'm glad that people like you are researching it. So thank you.
Thank you.
Remember, before you go, to grab your 1 penny bag of pine pollen for all the amazing, all-natural hormonal support that men and women the world over are raving about. Try it out and see how it works for you. All you have to do is head to geniuspollen.com to grab your bag today. Within days, you may be able to notice greater energy, more focus, added recovery, and more. Again, please visit geniuspollen.com to learn more now. Thank you.
If you like this podcast, please click the link in the description to subscribe and review us on iTunes.
You've been listening to the Finding Genius podcast with Richard Jacobs. If you like what you hear, be sure to review and subscribe to the Finding Genius podcast on iTunes or wherever you listen to podcasts. And want to be smarter than everybody else? Become a premium member at findinggeniuspodcast.com. This podcast is for information only. No advice of any kind is being given. Any action you take or don't take as a result of listening is your sole responsibility. Consult professionals when advice is needed.